Hi there. In this lesson, you are going to learn how to find the area of triangles using different formulas such as Heron formulas and some other standard formulas. In this section, you are going to learn how to find the area of triangles such as right triangle, isosceles triangle, and equilateral triangle. So let's begin. Right triangle. Let us consider right triangle with base B and height h. So let's consider right triangle. So this is my right triangle. Let this vertex is P, this vertex is Q, and this is my vertex R. Let the triangle is right angle at point Q. So this is my right angle. Let the height of the right triangle is H and the base of the right triangle is B. Then the area of the right triangle is given as A is equal to 1 over 2 times base times height. So let's substitute base and height, and if we do that, the area of the right triangle is A is equal to 1 over 2 times B times H. Now let's consider an example to use this formula. So my example is find the area of the right triangle with base 3 cm and height 4 cm. In order to solve this problem, what I'm going to do, I'm going to draw a right triangle. So this is my right triangle, and the triangle is right at this angle. Let the base of the triangle is 3. So this is my base, which is 3, and height of the triangle is 4, which is h equals to 4. So it's given that base is 3 and height is 4. Then the area of the right triangle is given as, what I'm going to do, I'm going to use this formula. A equals to 1 over 2 times 3 times 4. So 3 times 4 is 12. So I will write 12 over 2, which is 6. So area of this triangle is 6. Let's consider example of an isosceles triangle. So let us consider an isosceles triangle. So this is my isosceles triangle. Let this vertex is P, this vertex is Q, and this vertex is R. Since this is an isosceles triangle, so I'm considering side PQ is congruent to side PR. So basically the length of these two sides are equal. So if I'm considering the length of this side PQ as 6, then the length of side PR will also be 6. And let this side is 8, so my QR is 8. In order to find the area of an isosceles triangle, what I'm going to do, I'm going to drop a perpendicular from point P. So this is my perpendicular. So let this angle is right angle, and let this vertex is S. So basically what I'm getting two right triangles. So my first right triangle is PQS, and my second right triangle is PRS. If somehow I can find the height of this triangle, I can use the formula to find the area of the triangle. So in order to do that, I need to find the height. So if I drop a perpendicular from point P to QR, then this side will be divided in two equal halves. So basically my QS is 4 and SR is also 4. So basically QS is equal to SR, and both are equal to 4. Now let's use the Pythagorean theorem. So the Pythagorean theorem is c square equals to a square plus b square. My c is pq, so I will write pq square is equal to ps square plus qs square, which is over here. Now let's substitute the value. So I will write 6 square is equal to ps square plus 4 square, because my ps is 6 and qs is 4. And if I further simplify, I will get 36 is equal to ps square plus 16, because a square of 6 is 36 and a square of 4 is 16. Now let's simplify further, and if I do that, I will get ps square is equal to 20, which simply means that ps is equal to square root of 20. Now let's find the area of this triangle. So the area of this triangle is given as a is equal to 1 over 2 times base times height. So my base is 8 and height is root 20. So if I simplify this, I will get the area of the triangle as 4 square root of 20. So basically, this is the area of this isosceles triangle. Now let's consider another example to find the area of an equilateral triangle. So let's consider the equilateral triangle. So this is my equilateral triangle. Let this is vertex P, vertex Q, and this is vertex R. Let the length of all the sides of the triangle is 6. So all my sides are 6. In order to find the area of an equilateral triangle, what I'm going to do, I'm going to drop a perpendicular from point P. So this is my perpendicular, and let this angle is right angle, and let this is the vertex S. So basically what I did, my side PS is perpendicular to QS, and if I do that, I'm getting two right triangle, which is PQS and PRS. Now this perpendicular will divide QS in two equal halves. So basically QS is half of 6, which is 3, and SR is also half of 6, which is 3. So basically QS is equal to SR and both are equal to 3. Now let's use the Pythagorean theorem. So if I use the Pythagorean theorem, I can write C square is equal to A square plus B square. Now my C is PQ, so I will write PQ square is equal to PS square plus QS square right here. So let's substitute the value. So PQ is my 6. So I will write 6 square is equal to PS square. I need to find that plus QS is 3. So I will write 3 square. So 6 square is 36 is equal to PS square plus 3 square is 9. Now let's simplify. If I simplify, I will get PS square is equal to 27. So which simply means that PS is equal to square root of 27. Now let's find the area of the triangle. So the area of the triangle is given as A is equal to 1 over 2 times base, which is 6, times height, which is square root of 27. And if I simplify this expression, I will get area is equal to 3 square root of 27. And this is how we will use the formula to find the area of these type of triangles.